So at Glanris, what we've created here, and it was not my creation, we licensed it. We can talk a little bit about the backstory. But we've created a patented process that turns rice husks, the shell of rice, into an economical, environmentally friendly water filtration media that we call biocarbon. And actually the name is important because we don't call it biochar, which a lot of people would refer to this. Any biomass product that's been pyrolyzed, typically gets referred to as a biochar. But in the water filtration world, biochar has a bit of a negative connotation. And the reason for that is that there really haven't been strong standards applied to the production or quality of the biochar that's produced. So some of the people who have looked at biochar in the past have found that it was the quality varied so widely that they really couldn't use it. We're taking a very different approach to it in terms of both manufacturing and from a quality standpoint. So we felt that it was important to give it a name change. So that's why we call it biocarbon. So why rice husks? Rice is special for a couple of reasons. It has, for us, the husk of the rice, which is about 28% of the rice harvest, is very thin. So it's physically easy to pyrolyze and to turn into a char. And it's also very high in silica. So when we get done doing what we do with our process here, we end up with a material that's about half carbon, half silica. And in our process, and both in the pyrolysis process, which is how we char it, which is cooking it at high temperatures in the absence of oxygen. We also do some post-pyrolysis steps to activate the material. And it's during those processes that we're able to leverage the silica to produce some unique carboxylic groups that form around that give us the ability to remove dissolved metals. So again, two reasons why we like it: very thin, easy to pyrolyze, and the chemical properties. So, and just to touch on that for a second, certainly down in India and Sri Lanka, you see the use of coconut shell as being used for activated carbon. As a matter of fact, it's probably one of the leading for water filtration products, particularly drinking water and Brita filters, things like that, probably one of the leading sources of activated carbon there. So if you look at and just compare what it takes to prepare that, to pyrolyze coconut shells, first you've got to grind them up because they're very, very hard. And you got to grind it up into something that is a much smaller particle size. Then typically the kilns that cook it at 1,000 degrees C for 8 to 12 or longer hours in order to be able to pyrolyze it. When you compare that to rice hulls we could pyrolyze at about 400 degrees C in 10 minutes. So much less energy is required to do this than with a lot of other biomass materials. So just as a comparison to two sources that are readily available in India, you see great difference in the efficiency of using this biomass material. So the other reason why we like rice is that there's a lot of it out there. Over 220 billion pounds of rice hulls, the husks, are generated every year. So the United States is not one of the major rice producers. You guys are, I think, #2 in the world behind China. But I'm in Memphis, Tennessee, which is in the center of the country. And right across the river in Arkansas, the state of Arkansas, is where about 50% of the rice grown in the United States is based. So we have this rice belt here, which is, there are about 3 states right across the Mississippi River here that form about 85% of the volume of rice produced in the United States. So we're very close to the rice production. As a matter of fact, the largest rice mill in the world, I'm told, is in Jonesboro, Arkansas, which is where we get our rice hulls from. And there alone, they produce a little under 1 million tons a year of hulls alone. So it's a major waste product for them, and they're struggling with what to do with it. Historically, in the past, it's been burned. So traditionally it was just sort of left to rot in the fields. Then they would burn it to produce a char to leave in the fields. But it's actually not good to burn rice husks because when you burn them, you actually consume most of the carbon, and it's that carbon, that char, that gives it the beneficial traits for as a soil amendment. So when you burn it, you consume most of that, and what you're left predominantly with is silica. And silica is hydrophobic; it doesn't absorb water. So if you let that build up in the fields over time, you end up actually producing fields that don't hold water, and it promotes water runoff, which is not what you want in any of these agricultural crops. So they shifted from that to burning it for fuel. And it's not a very good fuel source, fairly low BTU, again, because it's very high in silica. So you end up at the end, either if you have a low temperature burn, you end up with the residue. If you burn it at low temperatures, you end up with silica ash in the furnace. And that silica dust is an inhalant risk. It's not, again, something that you want to mess around with. And if you cook it at too high temperatures, you end up melting the silica and it turns into glass, and you end up with glass in the furnace. And that's hard to get out. So it's a major problem for them what to do with the rice husk, because it's about 28% of the harvest. So it's a major component to the harvest. And when you take a look at what happens in India, it's the same thing. Most of it today is still being burned in the fields, and that's actually not what you'd want to do with this. You really should be looking at pyrolyzing it to turn it into a char so that it can have these other applications and uses. So I bring this up. We're getting a lot of attention for what we're doing, and some of the important things here for us in terms of the standards sides of things is that we have been certified by IBI as a certified biochar, and we have also gone through the process in that green bubble there of getting our NSF certification. We are NSF 61 certified. And what that means in essence is that we don't leach anything toxic into the water, and that we can filter to EPA standards. So, when you take a look at how does this compare to other technologies that that are out there, the two sort of main technologies that we compete against time and time again are traditional activated carbon, which is great for organic contaminant removal, and ion exchange resins, which is what you use a lot for metals removal. So when you take a look at how do we compare, we do the same things as activated carbon does, but we add the ability to remove metals. So we're a combination of those two from a functional standpoint. And really, when you take a look at how a lot of the other activated carbons are produced, they don't remove metals. Most of the activated carbon that we see out there today comes from coal. So in today's world, you don't want to be digging coal up out of the ground and turning it into an activated carbon. It's much more sustainable to use biomass materials, rice husks or wood or whatever else, biomass waste materials, and turn those into activated carbons. That's how you can address this from a sustainability standpoint. And, when we compare ourselves to ion exchange resin beads, well, we're not a microplastic. They are a petroleum-based microplastic, very effective at removing metals. But again, as a waste product, you end up with a lot of this getting back into, the environment, and we need to be removing these sort of microplastics from the environment. So, when we compare it, we're about the same cost as typical activated carbon. We're much less expensive than an ion exchange resin bead. And we're much more sustainable than either one of them today. So, what are we addressing today in terms of, the markets? Well, initially, we're looking at water filtration for use of this material. And there are three traditional markets in the water filtration world, which you guys know real well: industrial, municipal, and residential. And certainly in the industrial applications, we're seeing some traction really in two specific areas. Manufacturing firms that paint, plate, do something with metal, grind it, bend it, whatever, and use water to clean up and end up with metals in their wastewater and need to remove those metals before they can discharge the water. So that's sort of one high market for us. The other market is environmental remediation. And this is kind of a broad category. It's not just sort of Superfund cleanups. It's places like in California where if you want to dewater a construction site, when you move that water from one place to another, you're responsible for the contaminants in that water. So you need to filter it. And our media is a great sort of broad spectrum filter that handles, again, organics, whatever metals are in there. So you don't need to be very specific about the types of metals. Whatever's in there, we can generally handle it. For them too, what you also see is that they don't know what's in that water. There's oils, there's grease, there's a lot of gunk, there's a lot of different materials in there. And when you look at how we work, particularly in oils and solvents compared to activated carbon and ion exchange resin beads, you see that we don't foul as much as they do, and therefore can be more effective at removing the contaminants in the presence of those things. Municipal applications, obviously this is the big market. But municipals in the United States are very slow. Municipalities are very slow to innovate. There's very little incentive for them to change the filtration trains or technology that they're using today. And why is that? Well, because there's risk, right? If you change it and bad things can happen and people can get sick from the water, and obviously that's very bad. So there's actually a great disincentive to innovate with new technologies. That said, we have now 4 municipalities that have designed our product into their filtration upgrades. And next year we will actually be installing the first of these. So we're getting there, but it's very, very, very slow. And then the residential market, this is really 2 things. It's both the carbon block market, and here we've got a couple of products that the variants of our base product that are attractive there. But it's also in the pitcher market, replacing the activated carbon and ion exchange resin beads that are in a typical Brita or Brita type filter with our material. So early days in this, we're doing a lot of testing. This will also require additional certification beyond the NSF 61 certification, and we're working on those right now with several partners. So in terms of costs, I mean, again, this is sort of all over the board, and you guys certainly know your prices in your market better than I do. But when we look at how we compare with ion exchange resins and activated carbons, we're about the same price as activated carbons, but we're much less expensive than ion exchange resin beads. So again, what are our advantages? Right. Yeah. So again, the prices are all over the board. So when you go to price carbon, you might get a price of something as low as $15 a cubic foot. So we just picked what we know of as distributor pricing for this. So yeah, at our high end price, we're 30, they're 35. It's about the same price. Yeah, it depends. I haven't. There's not sort of one thing in the manufacturing side. For environmental remediation, it's really simple. It's just we kind of do everything, right? It's a Swiss Army knife of filtration products. And so when they go out to do a dewatering application, there's a little bit of everything in there. And we're good at taking out a little bit of everything. When you get to the manufacturing sites, sometimes it's because they actually care about the sustainability. Their chief sustainability officer has said, we need to stop using these harsh chemicals that we're using out there and see if we can, do something more environmentally friendly. And they all scratch their heads, and then we show up and they go, oh, this is perfect. It's kind of what we've already been using, fits in the same, exchange tank or filtration tanks or filtration train that we've been using. And we just take out the, activated carbon and ion exchange resin beads, put your stuff in, and we're good to go. So it really depends. We're trying not so much to compete on cost alone, but to get people excited about, a broader spectrum of applications, particularly sustainability. And in terms of the advantages, we do both. We do, we do metals removal as well as organics. Certainly cheaper than ion exchange resin beads, So, that gets some people excited about it. We operate in a much wider pH range. Typically, we've got less sensitivity, and to those swings. So again, from an environmental standpoint, you generally are dealing with some pretty harsh water when you do some cleanups there. So that works well for us. There's no pre-treatment required to adjust pH prior to using our material. Our stuff is lighter weight than than some of these other materials. So if you're paying to have it hauled to the dump, and the tipping fees are by the pound, it's less expensive. As I mentioned, we're sort of a drop-in replacement. We can go into the same filtration tanks that they're using today. We don't foul in the presence of oils and grease. And it says made in the USA, but really the point is it's made locally, globally. So we don't have to make it here and ship it around the world, which is not very sustainable. This can be made anywhere that rice is grown. India, Thailand, Kenya, Egypt, China, Philippines. I mean, on and on and on and on. Rice is grown globally, and you have a very inexpensive feedstock for this material on a global basis. As we mentioned earlier, it's much less expensive to produce this than to produce other activated carbons. And lastly, we qualify for carbon credits. We'll talk a little bit about that in a second. Who are we? Well, we're still very much a startup at this point in time. We have a 60,000 square foot facility here in Memphis. We've gotten our first production line up and optimized as of last summer. We've got the ability to produce about 3 tons daily, but certainly with our supply across the river here, and with a enhanced production line, we've got the ability to produce up to 2,500 tons a day with our current supply. We ship it typically in super sacks and in 1 cubic foot boxes, depending upon who's using it and what they're using it for. We've got 4 patents now, 2 in the US, 1 in China, and 1 in Japan. And we have a number of other patents pending at this point in time. As I mentioned before, one of the key sort of differences between us and other or traditional biochars is that we made the decision to have a lab to monitor quality so that what we're producing is consistent in quality, and to be able to certainly adjust production as we see issues there. Another thing, and again, we can talk more about this, and Frank can talk more about this too, as he's aware of some of these things. We have partnerships with 2 universities that we're working on enhancing our existing base biocarbon, which we call 901X. 901MB is a secondary treatment to our base product that gives it the ability to remove arsenic and other anionic materials, because today our material is predominantly cationic removal. So, and then we've got 901 Up. 901 Up has about 10 times the capacity for metals removal of our current product. And this is actually a product that's very exciting for carbon block production, because it can replace the Metsorb and ATS products that are added to remove metals in the carbon block products. And then we've also been looking at and been approached by people interested in using this biochar in a number of other applications: concrete, cement, asphalt, soil amendment. We hadn't really thought about those because these are traditionally low value added and certainly don't have the revenue per pound numbers that you'd see with water filtration competing against ion exchange resins, et cetera. But they use millions of tons of this material. So, part of the rationale for that is our partners, Rice and Foods, who's the largest rice grower here in the United States. As I mentioned before, they produce, at this one facility over here, over 1 million tons of this every year. And, they want us to take all of it, because right now it's a waste product for them and they're paying to have it hauled away. So we're looking at some of these other higher tonnage applications, which can take millions of tons a year of the product, and building a much, much, much larger facility adjacent to the rice mill to be able to produce this stuff in huge quantities. And therefore to be able to address some of these other markets. And we actually already have offtake agreements for these in the quite literally millions of tons level. So pretty exciting. And what that does for us on the water side is it reduces our cost for this material by about 90%. So be pretty interesting at that point in time to have a very, very low cost water filtration product. I mentioned before that we qualify for carbon credits, and I'm sorry I'm running over here a little bit. We did complete our life cycle assessment this year, and we have been determined to be carbon negative. Which means that we use less or produce less CO2 than is used or sequestered in this, which means that we qualify for carbon credits, and we are now up for sale, or those carbon credits are now up for sale on Puro.earth. And as I mentioned before, with some of these other applications that are much higher tonnage, we've got the opportunity to have much larger sequestration possible going forward. And just to touch a little bit about on that, the most recent UN IPCC report identified the production and use of biochar as one of the top 3 tools that we have in addressing climate change. And they estimated that it could remove up to 4.1 gigatons of carbon, or sequester 4.1 gigatons of carbon annually. And they were looking at it just for soil amendment. But when you start taking a look at its applications in asphalt and a lot of these others, others in the industry believe that those numbers are actually an order of magnitude higher. And so when you take a look at the cost for that, you guys may have heard about Climeworks, which is a group that's actually scrubbing carbon dioxide from the atmosphere and pumping it into the ground up in Iceland. Their cost to sequester a ton of carbon is around $1,000. Our cost to sequester a ton of carbon is virtually zero, because that sequestration of carbon is a byproduct of what we do for, what we're producing for water filtration. So the cost of the product's borne through the initial applications, whether it's asphalt or water filtration or whatever, and the sequestration comes for free. And so when you start taking a look at, how do we really address climate change with solutions that don't cost us $1 trillion, because that's what you're talking about. You got to get to gigaton scale, and to get to gigaton scale, if it costs you $1,000 per ton, you're talking about trillions of dollars to build these air scrubbers. Well, for us, we can be just as effective in the sequestration, and it lasts as long, if not longer. And we were talking hundreds to thousands of years, depending upon the application, than pumping it into the wells that they're doing up in Iceland, but for virtually no cost. So, we're certainly very excited about that potential of this business as well. So, thank you.